Good morning, students. In previous class we have learnt Graham's law of diffusion, Dalton's law of partial pressure. Now we will discuss about kinetic molecular theory of gases. So this kinetic molecular theory can explain the theoretical explanation for the gas laws. So finally gas laws explain the behavior of gases. Okay. So in before this we saw that Boyle's law, Charles' law, Avogadro's law, these are explained for the gases behavior by experimentally. But here what happened? The kinetic molecular theory of gases can explain the gases behavior by theoretically. That is a very important. That's why we should learn kinetic molecular theory to explain the theoretically by gas behavior. So now first we will see the postulates. Okay, so postulates of the kinetic molecular theory of gases. First postulate here, gas consists of a large number of tiny particles. Gases consist of large number of tiny particles which are called molecules. Okay, so which are called molecules. The molecules occupied by the volume, is very less compared to the container volume. Here container volume is large and the gases molecules occupy the volume is very less. That's why here volume occupied by the gas molecules may be ignored. Volume is negligible. This is a first postulate. And from these postulates we can determine that gases are highly compressible. Gases are highly compressible. That's why here the volume of the gas molecules may be ignored. This is the first postulate. This is the example for compressibility of gases. Gases are compressible highly. So this is the example. Next, second postulate. The attractions and repulsions between the molecules are also very negligible at ordinary temperature and pressure. Okay, so that means between the gas molecules there is no attractions or repulsions at ordinary temperature and pressure. So this postulate can explain that gases can expand and occupy all the available spaces. Okay, so from these assumptions, which assumptions? There is no attractions and repulsions between the gases molecules. So that's why gases can expand easily and occupy all the available space. Next, third postulate, that means gases molecules move in all directions with different velocities. Okay, and during this random motion, what happened? Collide with each other. Okay, so during this random motions, what happened? Gas molecules collide with each other as well as they collide with container of the walls. So that's why gases can exceed the pressure, because whenever during the motions or during the movement of the gas molecules, what happened here? They collide with each other as well as they collide with the container of the walls. So whenever the container of the walls collides the gas molecules, what happens? Some pressure exceeds. So that's why from these assumptions we can explain that gases exceed the pressure. Molecules collides with each other as well as they collides with the walls of the container. And the fourth one is molecular collisions are perfectly elastic. Perfectly elastic means no loss or gain of the energy. That's why we can call that molecular collisions are perfectly elastic. That means molecules' total energy remain constant after the collision also. Okay, so how much the energy exists of the molecule before the collisions, after the collision is also what happened? Same energy will be given. Okay, so that's why molecules total energy remain constant. This is a fourth postulate. And the last postulate, what is that? Fifth postulate, that is a kinetic energy is directly proportional to absolute temperature. What happened here? If take a container and take a gas in the container, what happened whenever the heated it, what happened? So whenever the heating it, these molecules having or move with rapidly, that means move with fastly, that means average kinetic energy is also increases whenever the temperature increases. That's why the fifth postulate can say that average kinetic energy of the molecules is directly proportional to temperature of the absolute temperature. That means temperature increases, average kinetic energy is also increases. So these are the postulates of the kinetic molecular theory. So once again repeat it. First postulate, the molecules is considered as a small particles. That means molecules are considered as a point charges. That means occupy the volume is negligible comparing with the container volume. Okay. Next one is there is no attractions and repulsions between the gaseous molecules at ordinary temperature and pressure. Next one is whenever during the molecules, what happened here? They collide with each other as well as they collide with the container of the walls. So that's why gases accept the pressure. And these collisions are perfectly elastic, means there is no loss or gain of the energy. Finally, molecules total energy remain constant after the collision also. And average kinetic energy is directly proportional to temperature. Whenever the temperature is increases, average kinetic energy of the molecules is also increases. Next, kinetic gas equation for the ideal gas. Okay, so kinetic gas equation for the ideal gas is a PV equals half mnu Rm square. Okay, so sorry, RMS. So here P is the pressure of the gas, V is the volume of the gas, and M is the mass of the one molecule, and N is the number of molecules, and URMS is the root mean square speeds. Okay, so whenever the gases is in the present of container, what happened? These gases molecules containing the different speeds, like most probable speed. So like this is also one of the type of speed is a root mean square speed. Okay, so it is nothing but one of the type of the velocity. So this is a kinetic gas equation. So this equation is also very important for the exam. Okay, the next one is deduction of the gas laws from the kinetic gas equation. Now we will see. First we will see the deduction of Boyle's law from the kinetic gas equation. Okay, so now what is that kinetic gas equation? Is a PV equal to 1 by 3 mnu Rms square, means root mean square speed. Okay, so next, so we will write this equation like this. For example, this is a 2 by 3 and it is also 1 by 2 mnu Rms square. If the 2 cancel, is finally the 1 by 3 mnu Rms square. Okay, so we know that the kinetic energy of the n gaseous molecule is 1 by 2 mnu Rms square. Okay, so this is the kinetic energy of the gases kinetic energy of the gases whenever the gas containing the n number of molecules. So here kinetic energy, here substitute here. So from this PV equal to 2 by 3. So what happened? Kinetic energy equal to 1 by 2 mnu RMS square. Okay. So from this we can conclude that. So our postulate is also what happened finally. Fifth postulate is the average kinetic energy is directly proportional to temperature. So that's why here you will write kinetic energy is directly proportional to temperature. So if you removing the proportionality, one of the constant is there, that is the proportionality constant, that is kT. Now kT is substituted instead of Ke. What happened here? PV is equal to 2 by 3. Next one is kT. So now here at constant temperature, what happened at constant temperature? What happened? This total value will be constant. So at constant temperature, PV equal to constant. So this is a which law? This is a Boyle's law. Boyle's law. Okay. So this is Boyle's law. PV equal to constant is a Boyle's law. So like this deduction of the Boyle's law from the kinetic gas equation. Next one is Charles law, deduction of the Charles law. So here one of the point is there, that is a here PV equal to what happened here? PV equals 2 by 3 kT. Now here, so here what is that? If your P is comes here, what happened? V equal to 2 by 3 kT by P. Okay, so here like this we write the 2 by 3 K by P T. Now here at constant, pressure, what happened? Constant pressure, this total term will be constant. So that's why here V by T equal to constant. So this is belongs to the Charles law. This is belongs to the Charles law. Now the deduction of the Avogadro's law. So to deduction Avogadro law, we take two gases containing the same value. For example, it is a gas 1 molecules. Okay, so in this gas 1 molecules we taken as a volume is same and the temperature and the pressure is also same. Next another gas is taken, that is a gas 2. So in this gas molecules are there, it is also same volume and the same temperature and the same pressure. So consider equal volumes of two different gases at same temperature and pressure. Okay, so equal volume but gases are different. Okay, so according to kinetic gas equation, what is that? You write the kinetic gas equation for the gas 1. What happened here? So P1 V1 equal to 1 by 3 M1 N1 U1 RMS square. So this is for the kinetic gas equation for the gas 1. Now write down the kinetic gas equation for the gas 2. So that is also P2 V2 equal to half M2 N2 U2 RMS square. since volumes are two gases, the volumes of the two gases is same as well as the pressure is also same. That's why here we can write the P1 V1 equal to P2 V2. So now here write down the another equation from this 1 by 3 M1 N1 U1 Rm square is equal to 1 by 3 M2 N2 U2 Rms square. Okay, so in this two gases temperature is same, temperature two gases is temperatures same. So as the temperature is same, that's why their kinetic energy per molecule is also same. So from this we can conclude that is a half M1 U1 M1 N1 U1 Rm square equals half, sorry here not N1, just kinetic energy is not 1 by 2 M U square like this. Okay, so M2 U2 Rms square. So here substitute, here already we know that is a 2 by 3 is a 1 by 2 M1 U1 Rm square N1. So this equation like this. Okay, so further modified here, this is kinetic energy. So here 2 by 3 is a 1 by 2 M2 U2 square N2. So this total term is this total term is kinetic energy. So this total term is also kinetic energy. So here 2 by 2 cancel, as well as kinetic energy is also cancel. So that's why here means like this. Another step is also you will write the 2 by 3 kinetic energy of the gas 1 and the N1. Next 2 by 3 kinetic energy for the gas 2. Next N2, kinetic energy cancel. So 2 by 3 cancel. So finally N1 equal to N2. So this is a N1 equal to N2 is nothing but the detection of the Avogadro's law. N1 is equal to N2 indicates equal volumes of gases containing the equal number of molecules. So from this we can conclude that Avogadro's law from the kinetic gas equation. So now detection of the Dalton's law of partial pressure. So to detection Dalton's law, if you take one gas container, that means one container is taken in this filled with gas 1. So what happened here? So here V is the volume of the gas, and this gas molecules can exert some pressure on the container of the walls. So that is called P1. So now write for the gas 1 kinetic gas equation. What happened here is a P1 volume is same. So that's why here 1 by 3. So M1 mass of the one molecule. Next this gas containing the molecules, number of molecules, n molecules, and this gas contain this molecule containing some speed, that is a U1 is a Rms speed square. So this is a kinetic gas equation for the gas 1. So here volume is same, and here this gas is taken out from this container and filled with another gas. So volume is same, but the filled with another gas instead of gas 1. So here is also gas 2 molecules is there. So gas 2 molecules is also exert some pressure on the container of the walls. So that's why the pressure of the gas 2 is that is P2, volume is same. So now here kinetic gas equation for the gas 2, that is 1 by 3 and M2 N2 U2 RMS square. So now same container of the container is same, but here what is that? Gas 1 filled with the gas 1 plus gas 2. So volume is same, but the both gas 1 and gas 2 both are filled the same volume. So now the total pressure is PV. So total pressure PT, V equal to now here 1 by 3 M1 N1 U1 RMS square plus 1 by 3 M2 N2 U2 RM square. So here half M1 N1 U1 RMS square is equal to P1V. So P total V equal to P1V plus here is also P2V. Now V cancel. So from this we can conclude that is a PT equal to P1 plus P2. So this is a Dalton's law of partial pressure. So it is this equation is deduced from the kinetic gas equation. So here which one is constant? Temperature and the volume both are constant. Okay. The last one is Gram's law will be deduced from the kinetic molecular theory. Okay. So according to kinetic molecular theory, PV is equal to what happened? PV is equal to 1 by 3 MNU RMS square. Okay. So here what happened here? One gas molecule mass is M. So now N gas molecule. So one molecule of the mass is M. So now from this we can conclude that so N molecules of the mass is Nm. So if the gas containing the Avogadro number of molecules, is nothing but how many? 6.022 into the power of 23 molecules are there. Okay, so now here n value, what is mean by n value here? 6.022 into 10 to the power of 23 molecules mass. So here 6.022 into 10 to the power of 23 we called as a 1 mole. So 1 mole mass. So 1 mole mass is called molar mass. We called as a molar mass. So molar mass means 1 mole molecules mass we called as a molar mass. It is represented by capital M. So now here capital M substitute instead of the M and N. So here now the kinetic rearrangement of the kinetic gas equation is PV is equal to 1 by 3 is a capital M and the U R M S square. So from this U R M S means under root now 3 comes here. So that's why here 3 PV is divided by M. So here D is equal to M by V. So this is a molar mass. This is called molar mass. So this is a molar volume. Molar volume means 1 mole of gas occupy the volume. 1 mole of the gas occupy the volume is called molar volume. And 1 mole of the That means 1 mole of molecules containing the mass is called molar mass. Okay. So now here substitute here. So what happened here? Under root 3p by under root d. Root of d is URMS. So now at constant pressure, what happened? At constant pressure, visualize the rate is also equal to URMS. So now from this R equal to constant by the root of density. So from this R is directly proportional to 1 by root d. So this is the which gas at constant pressure. It is a law of Graham's law of diffusion. Graham's law of diffusion. Okay. So like this deduction of the gas laws from the kinetic molecular theory. So once again repeated, what is that kinetic molecular theory? So kinetic molecular theory can explain the theoretical explanation for the behavior of the gases. First postulate. So gases consist of a large number of tiny particles which are called molecules, but the actual molecules volume is very negligible comparing with the container volume. So from this we can conclude that gases are highly compressible. And second postulate, there is no attractions or repulsions between the gaseous molecules at ordinary temperature and pressure. So from this we can conclude that gases can expand and occupy all the available space, and gaseous molecules are move in all directions with different velocities. So during their random motions, what happened? Collide each other, as well as the collide with the walls of the container. From this we can conclude that gases exert the pressure, and these molecular collisions are perfectly elastic, means no loss or gain of energy. From this molecules total energy remain constant. And the next postulate is very important, that is the average kinetic energy is directly proportional to absolute temperature. So this postulate is very important. So the question is rising from here. Write down the postulates for the kinetic molecular theory of gases. Okay. Or sometimes is also deduction is also. So gas laws are a deduction from the kinetic gas equation. Okay. So two questions are rising here. One is write down the postulates of the kinetic molecular theory of gases, and second one is a deduction of the gas laws from the kinetic molecular theory of gases. Okay. Thank you.